correct, but this is not the correct final answer. There's an x to the 1 here, and there's a property, or if you have x to the n over x to the m, it becomes x to the n minus m power. So this becomes 1 minus 2, which is -1, unless I'm missing something here. So your final answer could be 2x to the -1, but then it says, and that's kind of the big deal in this part of the course, is your answer should only contain positive exponents. This would not be considered correct. So while your answer does address that, like there's only positive exponents, you have to fully reduce, simplify here. So this becomes 2 times 1 over x. So the property here is if you have x to the -n, it becomes 1 over x to the n, like that, and that becomes 2 over x.
Okay.
As your final answer.
Okay.
So there's I don't know if it's in US history or government, but there's a voting, there's a description of voters where they do most of the vote, go down the ballot, but then they like lose interest. That's kind of what I see here, is like you got pretty much all the way through the problem, and then it's like just a tiny bit more to do.
Okay.
So the same thing does appear to happen in number 5. So we'll take a look at that. Oh, and let me grab, there's a properties of exponents. There's always a really good reference sheet. Let's see if this is the one. This is the one that I like. There are many out there. Sometimes it's good to have one of these printed out that you know all the possible properties. So, okay, this is really good to start, and then you rewrite it, and you really want that constant to be out in front. So it would be -2 a to the 8th over a to the 1 b to the 8th. This is good so far, but there's one more little thing to do, which is this can reduce. What
Okay.
and now that we did that in the previous problem, what does that reduce to?
-2 a to the 7th.
Yes, -2 a to the 7th over b to the 8th.
Okay.
All right. 6. We should just maybe work. I mean, there's a lot of good stuff here. I think there's potential for some uncertainty. So what I see is that you applied the exponent to x to the 1, or should have, which would have made it x to the -4 here, because you multiply. And that's what you did to the 2. You multiplied it. That's how you got -8. And then you applied it to the -4 to get +16. So what is not clear is whether you applied it to the negative here. You might be like, what do you mean? How do I apply it to the negative? So if that is unclear, there's kind of an alternate way to do this problem. Sometimes it's better to simplify inside parentheses first. You know what I mean by that, or is that totally not clear?
No, I get it. Yeah.
Okay. And that would be my preference, but it doesn't mean that my way is right or wrong, or your way is wrong or right. It just means that there's a path here that I like doing it. Now, what you did is fine. You just have to make sure you apply it to everything. So one of the reasons they don't put the 1 there is because they want you to forget to not multiply that, but you have to multiply everything. But you also have
Okay.
to apply it to the -1. So really, like, there's kind of this in-between step, which is it's everything is raised, including this -1. It's -1 to the power of -4. It's like, well, what is that? Well, we can get to that in a moment. But from here, if you the thing that I guess was a little bit also concerning is because you didn't have anything there, it looked like you combine x and x to the 16th to just x to the 16th, but because the bases are the same and there is at least a 1 there, it should be a different number, but really it's -4. -4 plus 16 is 12, and then the y to the 8th on the bottom, that's good there. So the only thing lingering is like what to do with this -1 to the power of -4, which is really weird and awkward, but that is what it is. So let's take a look at that. So first thing is that you can write -1 as a fraction. And then what the negative exponent does is it flips the fraction. So this becomes 1 over -1 to the power of 4. That's what the negative exponent does.
Mhm.
Okay. And then you're raising the top to the power of 4 and the bottom to the power of 4. Or you could simplify what's inside parentheses, and it's really -1 to the power of 4, which is positive 1. So what
Okay.
some students remember is that 1 to any power is always 1. That might be on that reference sheet. -1 to the n is either 1 if n is even, and -4 is even, by the way, and it's -1 if n is odd.
Okay.
So this might be one for me to give you another one like, or we can just keep going for this.
Can I have another one like that, please?
Sure. All right, so this is like 6. Let's go -y cubed times x to the -4th y to the -3 power. So I'm going to step away for a moment and try working that out. I'll be back in about a minute. I'll check with you.
Okay.
Let me know if you have any questions or if you got an answer.
Okay. Almost. Um. I have x to the 12th power over y to the 12th power.
Okay, like that.
Yes.
Very good. That is correct. Okay. 7 looks good. Wait. is that a negative in your answer?
Yes, negative 16 over x to the 6th power.
So I feel like I'm like a lawyer. Like, where did it come from? There's no negatives here. Where did it come from? Uh, I don't know where it came from. That's why I asked, because there's no negatives here. There's none here. Um,
I don't know either.
jury, the witness doesn't know where the negative came from. But yeah, I don't know. I mean, it almost looks like, well, I think it was after the fact. I think he wrote this, and with that, we'd need a handwriting expert to know for sure. Um,
Yeah.
I don't know, just some thoughts there. Okay, let's look at number 8. Number 8 here. So like what I'm seeing here, this is so typical with these rules are they generally increase the difficulty too quickly, and you don't get enough practice with them, and then they throw these hard problems that you just don't know what to do. So everything in here is fine except for you didn't raise -2 to the power of 3. So it's kind of like that problem, that earlier one, like you almost want to rewrite the numbers as being in parentheses to the power of 1. So that you
Yeah.
know to apply it there. Because what
Okay.
that does is it affects this number, it becomes -8. Okay. Uh, and then we didn't cover this one yet, but x to the 0 power is 1, or anything to the 0 power is 1. That's good. That's maybe why you kind of got it crossed out. So what I see here, and let's start with this, is -2x to the -2 power, y to the 4th times -8. Well, it doesn't have to be in parentheses. Let me just not do that. Times -8 y to the 12th. Okay. And like, I don't know, it looks like the x just got dropped or something. I couldn't tell you. But you multiply the whole numbers, 16. Your x is going to now be on the bottom, x squared. And then it's y to the power of 16, because that's 4 plus 12.
Okay. Okay.
So I guess let me make one like this for you to try, if that's okay.
Okay.
All right. So like 8, -3 y to the -4 x cubed times -5 y to the 0 x to the 3rd to the power of 2. So I'm going to just step away again for about a minute and be right back with you.
Okay.
All right, I am back.
Okay. I have 75 x to the 9th over y to the 4th.
like this.
Yes.
Would you be surprised to find that the final answer is actually negative 75?
Yes.
Okay, so it's negative 5 squared, y to the 0, x to the 6th. And
Oh.
you have to treat this whole number. That's what I'm somehow just gonna have to try to get you to see. That might be the most important thing in this lesson. It's the whole number to the power of 1, not just the 5.
Right.
If you look at it as the 5 to the power of 1, you then also has to look at it as negative 1 to the power of 1. It's better just to look at it as negative 5 to the power of 1.
Right. Okay.
Is your quiz free response like this or multiple choice?
Free response.
Okay. All right. So you'll get some credit for that. I'd like to rework 9 from the beginning. I can correct your work, but let me suggest an alternate path. All right. And
Okay.
the alternate path here is to simplify inside parentheses first. Okay.
Okay.
So that means looking at the bottom first. The bottom becomes negative 2 u to the 3rd v to the 8th. Please look at that and let me know if you have any questions about how I came up with that.
No, I got it.
All right, now the 2's cancel. That's good. It becomes 2 minus 3, which is u to the negative 1. Now, when you use this property, it always goes in the numerator. So it's u to the minus 1, and we can move it back to the bottom, but when you subtract the exponents, it always goes in the numerator. And then it's v minus 3 minus 8, which is v to the minus 11. And then the negative can float, so it could actually move up to the top if you want here.
Okay.
So now we're going to use the negative exponent rule, which is that this is 1 over u to the power of 1 times 1 over v to the 11th negative. So we're left with negative 1 over u to the 1st v to the 11th. And now this is all raised to the power of 3. Now, the reason you do the stuff inside parentheses first is that it makes the power of 3 easier to deal with. It's hopefully you see that it's a little bit less work. So this becomes negative 1 to the power of 3, which is negative 1. And then you're multiplying the exponents here. U cubed v to the 33 power like that.
Okay.
So do you want me to check your work and try to find where we went different? Or do you want to redo it here like this?
No, it's okay. I like that way.
Okay. So what we just did applies to a problem like 6. You kind of can get away with it by not doing that first, but really the more complicated ones you do want to attempt to try to simplify first.
Okay.
Okay, up to 8, 9, 10 to 10. 10, 10, 10. Okay. All right. Okay, let me grab part of your response here. I'm gonna grab all of it, I guess. All right. So we got some good stuff here, but that negative, and you know that now, that negative here in front raised to the power of 2 makes this positive.
Right.
-4 is fine. -2 u cubed v the -1 is fine. This is all fine here. It's weird to have this, but you did correctly move it up to the top, which I like. Although you dropped the negative, well, you just brought it down here. Okay, that's where it came from. So that's positive because of that one there. And then this one again, you gotta, like, I would probably work on the numerator. Or if you go to this line right here, like you can't have u's in the top and the bottom. Just like, and you can't have, you got two u and u cubed. So the numerator here becomes -4 u to the 4th over u to the 4th v cubed. And then these cancel. Like that. So really, really close.
Okay.
11, and it's a small little thing. And it's the problem is I don't know how your instructor will mark this, if they'll say, it's really close. And so the small little thing on this one is that the -2, -3 should be +6 here.
+6.
And that impacts everything else. Although I take that back, you got the right answer. 4. Interesting. So, I mean, you got the right answer, but I don't know if an instructor would notice that when they're grading it.
Okay.
It could be, so the way that works is 6 minus 2 is 4. So you have a to the -1 over a to the 4th. -1 minus 4 is a to the -5, which becomes 1 over a to the 5th, which is how you end up getting it. So, I mean, you make a wrong turn, and then you make another wrong turn. Sometimes you get back where you were going.
Right.
Sometimes. Are you driving yet?
I have my permit.
Cool. All right. Let's looking at the next one here. So we got a sign error on that, but everything else looks okay. Seventh, 19th. Okay. So the only minor thing, but like if this were multiple choice, I would have all the possible sign errors on there, but I'm not making your test. That's why I'm bringing it up. And the signs are really important. It's like the issue was this -2 should have been raised to the power of 4. And that gets you the 16, but the 16 goes to the bottom. And then the negative is it's still there from the beginning.
Okay.
Okay, so a couple things here in the scientific notation. Did this get covered in class?
No.
Okay. So this is one of those times where I wish you hadn't seen anything, you hadn't done anything here, because nothing would have been better than what you did, because it's like a bad habit, basically. The way to do these is to first multiply these numbers and then to multiply these numbers. Right, so the powers are kind of the easy ones. It becomes 10 to the fourth. Okay. And you are allowed to use a calculator on these. So if you got a calculator handy, um,
Okay.
okay, so the issue here is that this new number is not in scientific notation. And what that means is, and it's not that you did anything wrong with yours, it's just that there's a better way to do it. This number on the left here, you can rewrite as 5.1084 times 10 to the 1 times 10 to the fourth, like that. And what that does is you then multiply the exponents again, but you're not counting zeros, I guess is the point.
Okay.
Okay, so 14 is the same. You got 10 to the 0 and 10 to the 1. This is 10 to the 1, and then you've got to multiply the two numbers together here.
Okay. 58.176.
Right, and then you move the thing over, so it becomes 58 times 10 to the 1 times 10 to the 1.
Okay. So, so then it's just times 10 squared.
Yeah.
Okay.
Okay, so the multiplication, hopefully you got a better handle on how to do that, and we should then move. So the preferred way, I was about to say proper, but that's not right. It's preferred way here is kind of like the previous one. You do this in parts. You do the 7 divided by 4.8 and the 10 to the 4th divided by 10 cubed. So it becomes 10 to the power of 1. And then hopefully this works out nicely. Usually it does.
Mm.
And unfortunately it doesn't. So they usually pick problems that work out nicely. So I guess that's why you rounded, but I don't know what to say because normally they pick something like 8 over 1.25 or something that actually works out. Actually, I don't know if that works out. Like 6. I don't know what to tell you. I would ask your teacher about this one, but that is my opinion. And then
Okay.
the last one you've done is correct. There's not really much to change on that. 15 is fine.
Okay.
All right. We've got some time left. Would you like us to work on some similar problems?
Can we also worked on like inequality problems with like interval notation and like plotting points? Can we do like problems like that?
Do you have an example? Because what you said, I've got a lot of directions I could go on that.
Wow. Like uh I'll send a picture of the note page. Okay, there it is. Oh, well, absolute value. We did absolute value. And then we also did, he would give us like a number line and we would have to write like inequalities and stuff, right?
Okay, so I mean, what I heard here is like, let's say I give you a number line like this, and that's -3, and I show you this. I don't know, and you would have to write an inequality from that. Is that right?
Yes.
All right, so you need the variable, which you don't have, so we could use X. So if it's going left, left is typically these two symbols, okay? And if it's an open circle or filled in circle, you use the appropriate one. So the filled in circle includes, this excludes. Okay, now if it's going to the, so this would be X less than or equal to -3.
Okay.
Now let's say it's 2, and then it's to the right. So when it's to the right, it's greater than open circle, greater than or equal to filled in circle. Same thing here, includes, excludes.
Okay, so X.
So it's, yeah, greater than 2. And then the last possibility, well, not the last possibility, the next possibility is the between. So it might be like -4 to 6. And it could be that, one is open, one is closed, or not, but you put the variable in the middle, the number, and then the number. And then the signs always face left, or the inequalities face left.
Okay.
The other possibility is what I call outside. So here's your number line. Let's say that's -8, and that's -4. And it could be to the left, and then it could be to the right. And this is just the combination of the ones that you've already had, except you have to add a word in the middle, which is the word or. So outside is the word or. So sometimes the between case is called the inside. Sorry for all the scrolling. And it is associated with the word and, but it's encoded into the inequality here. So you have to know all the possibilities.
Okay.
Okay, so like, I guess I could give you some ones to try here. I feel like the multiple choice would be better though. Does that kind of answer what you wanted to do?
Yeah, I'm good.
To inequality. Let me see if I can find some practice problems here. One of the issues is one of the issues here is that I don't want you, I don't want us to get into like where you don't tell me the right answer. So well, here's what I'll do. Let me give you a couple here to write. These are all singles. These aren't that good. Okay, never mind. Let me see if I can find one more reference. Let me have you try these 4. And just let me know when you're done, and then I'll write the answer.
Mm-hmm.
So you can skip 4 because it's the same as 3.
Okay, then negative x's. Wait, okay. Negative
Let me,
3.
okay, that's what's we're at. I just write them all down. I don't want you to try to say them because that's where the issues come up. Just get all the answers down and then I'll write the correct answers.
Okay, I have them then.
Okay, so the first one is like this. Is that what you have?
Yes.
Okay, now the way to read this, there's a couple ways to read this, but the best way is to say x is between -3 and 5, -3 exclusive, 5 inclusive. Or say x is between -3 and 5, exclude 3, include 5. But that's kind of awkward. I can't, next one is x less than -5. Is that what you have?
Yes.
Okay. And then the last one here, something like that.
Yes.
Okay. All right. What else would you like to cover today?
That's all.
You sure? We got a couple more minutes. Get this quick question or two in.
No, it's okay. Thank you.
All right. You go ahead and stop the